solving three variable linear systems. How? By using matrices. Solving three variable linear systems using matrices. The date or the lesson number is 4.6, and be sure and include today's date in your notes. Okay, students? So with that in mind, go ahead and copy this down, please. I'm going to move on, but go ahead and copy this heading down. We are going to learn today how to solve three variable systems by using matrices. I think it'd be really, really wise to review for a second so that there's no confusion with the different methods we have learned already, okay? Now we have learned three ways to solve two variable linear systems. Do you remember what a two variable system is? It looks something like this. I'm just making this up, okay? There we go. And we call this a two variable linear system because there's two variables, x's and y's. We call them linear because the exponents of all the variables are ones. Okay? So you should recognize this. We call this a two variable linear system. Okay? Now we have learned three ways to solve these types of systems. We have learned the graphing method, okay? That is where you would take each one of these equations, graph them on a coordinate plane. You might get a line here and a line here, and where they intersect is your answer. That's the graphing method. We have also learned the linear combination method. Now that's where you try to get one of the letters or the variables to cancel. For example, I have a -3 here, so I would multiply the bottom equation by 3 so that I get a 3 right here, so that when I add these together, my y's cancel. You should remember that. It's called the linear combination method. We call it linear combination because you're combining your two linear equations. You're adding them together. Another method we learned is substitution. That's where you would take this y right here and get y all by itself. Bring the 7x over and make it negative. Y equals 12 negative 7x. You pick that up and put it in for y right up here and then solve the equation. Okay? So that should all look familiar. Now, we learned one way, not two, not three. We learned one way to solve three variable linear systems. And that one method we learned was linear combination. Remember, if I had x plus y plus c equals 10, 2 negative 2x minus 3y plus 7 equals 2, and 4x minus 5y plus c equals 3. Remember, we take two equations and eliminate, let's say, our x's, then take two other equations, eliminate our x's, but then we're left with two equations with two variables, then we try to eliminate one of those variables, so on and so forth. That was really the linear combination method because you were combining or adding two equations together. Okay? Well, we are not going to learn another method for two variable equations today. Now we're going to learn other methods later. In fact, pretty soon. The very next lesson in your algebra book talks about Cramer's rule. Cramer's rule, and we're going to use matrices to solve two variables. But today, we're going to learn a new method for solving three variable linear systems. Okay? So, today, like I just said, we'll be learning a second way to solve three variable linear systems by using matrices. So here we go. I'm not going to give you steps, students, for this procedure, so you will want to take a lot of side notes as I explain what we are doing. And by the way, there are different reasons why I don't give steps. Sometimes I don't give steps because it's just too difficult to put into words what we're doing, so it's easier to give you steps and comments and different things like that just to show you what we're doing instead of steps. Another reason sometimes that I don't give steps because the math really doesn't, it's not necessary. It's just kind of like do a couple things and you're done. And believe it or not, that's the reason for today. It's of something you're going to do to your matrix to get out your result. And so that's why we're not going to look at steps today. So as usual, I'm going to put the problem up here, and you can copy it. You can pause the video and copy it down, or you can try to take notes while you're copying it down. That's up to you, okay? Alright, now, I leave those types of decisions up to you guys. Now, first of all, I want to show you that if I take the numbers with the variables 1, negative 1, 2, negative 2, 3, negative 5, 2, 1, 1. I took these three variables here, 1, negative 1, 2, put them here, negative 2, negative 2, 3, negative 5, I put those here, and 2, that should be a 0, and I apologize, it's my fault. Make that a 0, please. 2, 0, and 1. If I take all of the coefficients and put them in a matrix, this is called a coefficient matrix. Okay? C-O-E-F-F-I-C-I-E-N-T, coefficient matrix. You need to know that. You need to know what to do when I tell you, hey, write a coefficient matrix. For example, you might want to write this in your notes. If I had a linear, actually, it's right here, I can just do this. If I had a linear system like that, and I said write the coefficient matrix, you would put 2, negative 3, 7, 1, because your coefficients here are 2 and 7, and your coefficients here are negative 3 and positive 1. So you do need to know what a coefficient matrix is, and it's very simple, is it not? I mean, that's amazingly simple, but as simple as it is, you still need to know what a coefficient matrix is. Got it? Now, next, you need to know what an augmented matrix is. Augmented matrix. Now, I thought about typing all of this. The reason I didn't is because of the actual matrices I've got to write out. It's quicker just to write them out. So, an augmented matrix is when you take a system like this, and here's what you do. Please watch carefully. Okay, now, thanks for your patience there. An augmented matrix is when you take a coefficient matrix like this, and then you put dotted lines like this, or a dotted line like this. Take good notes on this, please. And then you add the constant terms. 9, negative 4, 10, 9, negative 4, 10, okay? This is called an augmented matrix. Got it? Look at those two. Know the difference. I'm going to move on, so pause the video if you need to and back it up and watch again if you're confused. A coefficient matrix takes just the coefficients. Augmented matrix takes all the coefficients, puts a dotted line where the equal signs are, and then puts the constant terms. Now, we are going to solve this system by using an augmented matrix. So, when I ask you to solve a 3-variable linear system by using matrices, this is what you do right here. This is it. Okay? You write an augmented matrix. Now please listen to me carefully. Your goal is to get a 0 here, a 0 here, and a 0 here. That is your goal. You don't care about anything else. Let me say that again. Your goal is to get a 0 here, a 0 here, and a 0 here. Now take notes on that however you want to. Now, a couple things. The best way to do this is always get this 0 here first. I would make a note of that somewhere in your notes. Somewhere take a side note. That's the first 0 you want to find. Let me explain why. Because after you get a 0 here, okay, let me back up. If you get a 0 here first, and then you try to get a 0 here next, just trust me, I'm going to show you later how to do this, but you accomplish this by adding rows together. Well, if you add a row down trying to get a 0 here, then you're going to lose the 0 here. Just trust me, that happens, okay? And I'll show you that later, but for right now, always try to get your 0 here first. That's really, really, really important. side you asked. You can multiply your rows by anything, or you can add any two rows together. So come on guys, if I want to get a 0 here, what's above this -1? A positive 1, right? Sure it is. So if I were to take my top row and add it down to my bottom row, that would give me a 0 right here. Now I want to warn you, are you listening? Change one row at a time. I would write that down. I would always change one row at a time. That's the at symbol, at a time. Do not try to, you can change 2 or 3 rows at a time if you want, but it's very dangerous because you really are likely to make some mistakes. So I'm going to change this middle row by making this a 0. Now here's how I do it. If I'm going to change the middle row, then the top row stays the same. And the bottom row stays the same. See how easy that is? Just copy them over. Now, I'm going to take this row here and add it to this row. What's 1 plus -1? 0. What's -2 plus 3? 1. What's 2 plus 0? 2. What's 9 plus -4? 5. Look at that, that's so easy. Do you see it okay, guys? It's really not difficult. Now, so you're allowed to multiply a row by anything, and you're allowed, except 0, do not multiply a row by 0. You can multiply a row by anything except 0. You can multiply by negative numbers, positive numbers, whole numbers, fractions, decimals, it doesn't matter. And you can add rows together. So here's what I'm going to do. Are you ready? I know I want to get my next 0 here. I've taught you that, right? Well, think about it. Man, it'd be so sweet if I had a what right here? A -2. If I did a -2 right here, I could add this row to this row, and what do I always say, guys? Booyah, I'd have a 0 right here. So if somehow I can get this to become a -2, and you're like, well, duh, Mr. Earhart, multiply it by a 2. Okay, good idea. If I multiply this top row by a 2, I'll have a -2. Now here's where students make mistakes, and you are welcome to totally disregard my advice. That will not offend me. But if you make a mistake, don't forget I told you so, okay? A lot of students like to multiply this by 2 and then add it to this row all in one step. I don't do that. I change one row at a time. So my bottom row stays the same. Excuse me. My bottom 2 rows stay the same. Alright? And now I'm going to change my top row by multiplying it by 2. So -2, -4, +4, +18. Okay, so I changed my top row. Now I'm ready to add this row down to this row. Okay, so here we go. -2 plus 2 gives me a 0. -4 and -5 is -9. 4 and 1 is 5. 18 and 10 is 28 there. Now the top 2 rows stay the same. I am a stickler about changing one row at a time. Have I said that before? Just kidding, I know I have. To me that's just really, really smart. Tedious and long, I know, but still. Now I am going to break that rule for just a second. Now watch, I'm going to break my rule just one time. And I'm going to show you how. I want to get, now watch, actually I'm not going to break my rule, sorry. But look guys, please, if you've not listened well up until this point, please listen well now. Don't miss this next point. Would you pretend for a second that you had a +9 right here? Pretend you had a +9. Don't write that in your notes, just watch. If you had a +9 here, you'd be like, dude, cool, I'm going to add this row to this row. Don't do that. If you add this row to this row, will you get a 0 here? Of course you will. But you'll lose your 0 here. -2 plus 0 is -2. Let me go over that again. Look, if you have a +9 here, and you add this row down to this row, That's not going to work. Yeah, you'll get a 0 here, but then you get a -2 right here. That 0 will be gone. So when you go to find your last, 0 right here, always use the second row, because when I add this row to this row, 0 plus 0 leaves a 0 right here. Let me say that again. When you go to find your last 0 right here, always use your last 2 rows. That's the smartest thing to do. Now I've got a 1 right here. I sure wish that was a 9. Wouldn't that be great if that was a 9? I could add this row down and get a 0 right here. Well, if I want that 1 to be a 9, we can take care of that pretty easily. I'm going to multiply this row by 9. And so, here we go. 9 multiplied across in the middle row would be 0, 9, 18, 45. Got it? Up top, nothing changes, so -2, -4, 4, and 18. Bottom row, nothing changes, 0, -9, 5, 28. Now, I hope I've not made a mistake anywhere. They're so easy to do. I'm going to add the middle row down to the bottom row and change the bottom row. So here we go. 0 plus 0 is 0. 9 and -9 is 0. 18 and 5 is 23. 45 and 28 would be 73, I believe. Okay, students, I'm back. Guys, I really hate this, and one thing you know about Mr. Earhart, I will work very hard for you. I make sure your videos are ready, test corrections, quiz corrections, etc., etc. But I'm about 15 minutes into this video, and I'm not going to redo that. I just noticed back here I made a little mistake, and you guys probably saw that earlier, and I really, really hate that. And what can I do, guys? You know, if I was in the room, someone would call out, Mr. Earhart, you brought a negative sign down when you weren't supposed to. And I would have said, oh, thank you, and that would have been it. But if you'll look right here, notice this 1 right here became a -1 for no apparent reason, okay? So, I'm sorry. You're welcome to start a new sheet of paper. You're welcome to break out your eraser. But I am going to have to go back to here, and I hate that so much. And I feel so badly about that. I really do, okay? But I've got to admit my mistakes and go on, okay? So, the first thing we did was we added row 1 to row 2 to get a 0 here. Now the next 0 we want to get is right here, okay? Well, think about it. If I just had a -2 right here, that would be perfect. So I can get a -2 by multiplying this top row, not by 2, like I told you before, but -2. So if I multiply the top row by -2, I'm going to get -2, +4, -4, -18. Now let me pause and say this. We're going to do one more of these, and you have my word on this. On the next one, I'm going to pause the video, draw everything up, and make sure it's perfect, and then kind of go through the slides that way so this mistake thing won't happen again. I'm very sorry about that. Okay, so I multiply by -2 through, and I get this. Everything else stays the same. Alright, now I'm going to take this top row and add it to my bottom row, and my bottom row will be a 0, a -1, a -3, and a -8. Alright, -2 plus 2 is 0, 4 and -5 is -1, -4 and 1 is -3, -18 and 10 is -8. Now, nothing else changes. As you can see here. So students, we have a 0 here, a 0 here. Now our next goal is to get a 0 here. Now, like I told you earlier before I made my mistake, when you try to find your last 0, always use the last 2 rows. Rows 2 and 3, please, students. Trust me on this, okay? Well, look, they're actually set up pretty nicely. I've got a +1 here. here. So if I add my two bottom rows if I add my second row to my third row, that'll give me a 0 right here. So actually that works out pretty well. Okay, so 0 plus 0 is 0. Negative 1 plus 1 is 0. 2 plus negative 3 is negative 1. 5 and negative 8 is negative 3. Alright, now my other rows do not change, so I'm going to leave those alone. Alright, so I've accomplished my goal. I have a 0 here, here, and here. Now, students, the reason I've got these zeros here is watch carefully how cool this is. I can now put my x, y's, and z's back in. So go to your top equation here. Negative 2x, positive 4y, negative 4z equals negative 18. Alright? Next equation. 1y plus 2z equals 5. Look at that. Bottom equation. Negative c equals negative 3. Do you see it? Negative 2. I put an x here, a y here, a z here, and an equal sign here. I put a y here, and a z here, and an equal sign. I put a z here, and an equal sign. Look at that. Look how much that helps. I can solve this so quickly. Let's start off with your bottom equation. I'm going to clear some space here, okay? And I do apologize again for that earlier mistake. I hate that. And like I said, when I go to the next problem, I'm going to pause the video, work the whole thing out slide by slide, and then just hit next page. So that won't happen again, okay? But boy, be careful when you do this, because it's really easy to make mistakes. Anyways, bottom equation, negative c equals negative 3. Well, if negative c equals negative 3, then c equals what? 3. Now go to your next equation where the c is right here. What are you going to put? 3. So y positive 2 parentheses 3 equals 5. Y positive 6 equals 5. Bring your 6 over and make it negative. Y equals negative 1. So now I know what y equals. Now I go to my next equation, and where the y is, I'm going to put negative 1. Where the c is, I'm going to put 3. Negative 2x, positive 4, parentheses, negative 1, negative 4, parentheses, 3, equals, that's a 3 right there, equals, my pen's messing up, sorry guys, equals negative 18. Alright, and so here we go. Negative 2x, 4 negative 1 is negative 4, negative 4, 3 is negative 12 equals negative 18. Combine these two like terms, negative 2x, negative 16 equals negative 18. Negative 4, negative 12, negative 16. Bring your negative 16 over and make it a positive 16. Negative 2x equals negative 2. Divide both sides by negative 2. X equals 1. And that is the correct answer. Okay? Students, there we go. That's it. So, look, your goal in this augmented matrix is to have a 0 here, here, and here. Find this one first, find this one second, and find this one third. And when you find your last one, be sure and use this row here and this row here. Those are the two. I better put check marks, not X's. Be sure and use this row here and this row here to find your last 0. If you don't do that, you could run into trouble. Okay? Alright. Now, you're going to probably disagree, but for me, to be honest with you, I actually like this method better than the method we used before to solve 3-variable linear system. That's just me. I know it's a lot of tedious work, but I like getting rid of the letters, quickly finding my zeros, and then solving. That's just me. Alright? Matrices are helpful in a lot of different ways, and this is one of them. Now, you might not like this method, but tomorrow, well, the next time we have a video, Kramer's rule, you're going to like that. It's going to really show you. It's really a quick way to use matrices to solve linear systems. Okay? Let's take a look at pause the video, work the problem on your own, and then restart the video to see how you did, okay? That's totally up to you. There's our video, or excuse me, there's our problem, okay? So let's go ahead and take a look at this. Okay, students, I'm back. I did what I said I would do. I paused the video, and as you can tell, I have worked out the entire problem here for you, so that hopefully, well, not hopefully, so that no mistakes were made. And by the way, I did make some mistakes, so I'm glad I did it this way. Okay, whether you've worked ahead or whether you're watching me do it, whatever, that's up to you. Now understand, since I've pre-typed it, then the slides go a little faster than usual, so you probably have to pause the video a ton during this next during this problem, but that's okay. At least there's no mistakes. Okay, so here we go. The first thing you want to do is write an augmented matrix. Okay, so what I did is I got rid of all these words. I slid this problem up to the top corner like this, and I wrote my augmented matrix. Okay, so I took my coefficients here and put them here, coefficients here, put them here, coefficients here, put them here. For the equal signs, I put my dotted line, and for my constant terms, I put them right here. Okay, so there's my nice augmented matrix. Now, the next thing I said to myself is self. I have to get a 0 here, a 0 here, and a 0 here. Now, what did Mr. Earhart teach me? He taught me to find this 0 first. So, how can I get a 0 here? Well, hold it. I can multiply. If I could make either this a -1 or this a -1, then I could add this row here to this row here and get a 0. Now students, listen, please trust me, it really doesn't matter which one of these ones you make a negative. I chose to do the middle one, so I'm going to multiply this middle row here by a -1. So I'm going to put a -1 here. Does everybody see why? If I multiply this middle row by a -1, that'll give me a -1 here, and that's good. Then I can add this row up to this row, and it will cancel. Now, if you chose to put your -1, and I've got to be careful here. Okay, if you chose to put your -1 down here instead of up here, that's totally fine. You'll still get it right. Okay, so I chose to put my -1 here and multiply it through. When I did that, this is what I came up with: -1 times 1, -1 times 3, -1 times 10, -1 times -10. All of my signs here change: positive, 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 negative, negative. It's now negative, 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 positive. Now I'm saying to myself, okay, I want a 0 here. I'm not going to add this row down to this row. No, that's not what I'm going to do. I'm going to add this row up to this row and change this row right here. So I'm going to take this row and add it up to this row here. Okay? Now when I do that, here's what I'm going to get. Watch carefully. 1 and -1 is 0. 2 and -3 is -1. 5 and -10 is -5. -11 and 10 is -1. Now I know I'm going way too fast, but at least I'm not going to make any mistakes. And by the way, I made 3 mistakes on this. When I paused the video and did this all the way to the end, I made 3 mistakes. Watch your little mistakes. It's easy to do, okay? But you've also learned that I grade very fairly when you prove to me that you know what you're doing, and you make little mistakes. But nonetheless, be careful, okay? Now, I took the bottom row, added it up to the middle row, and changed the middle row. The top row and the bottom row did not change. Now I'm saying to myself, okay, Mr. Earhart taught me to get this 0 next right here. Okay, so how can I get a 0 right here? Well, I'm thinking if I could somehow make this 1 become a -3 right here, that would be perfect. I could take this row here, add it down to this row here, and get a 0 here. So somehow I've got to make this bottom number become a -3. Well, guys, we know how to do that. If you multiply this bottom row, and by the way, there's no negative sign here. So if I multiply this bottom row right here by a -3 right here, a -3, the same as these two rows right here. Did not change. Now I'm ready to do what? I can take, do I want to change my top row? No, I want to change the bottom row. So I can now add my top row down to my bottom row and change my bottom row. So if I do that correctly, watch what happens. 3 and negative 3, 0. Hey, a double whammy. I got 2 for the price of 1. Look, positive 6, negative 6, 0. 6, negative 15, negative 9. 3 and 33, 36. Now would you please listen to me? Pretend for a second that you didn't have a 0 here. Pretend you had another number like 8. Okay? Don't forget, when you go to make this a 0 after you found this 0 and this 0 and you come to find your last 0, which 2 rows do you always use? This row and this row. Do not use your top row when it comes time to find your last 0. Please don't do that. Okay? Alright, but in this case, we don't have to worry about it. When we went to get this 0 here, we luckily got this 0 also. Awesome. Now, because I have a 0 here and a 0 here and a 0 here, I'm now ready to go back and put my x's and my y's and my z's back in and write my 3 equations. So if I do that, they'll look like this. There it is, right there. I put an x here, a y here, a z here, equal sign here, a y here, a z here, equal sign here, a z here, equal sign here. And now we know what to do. Start with your, well, first of all, I'm going to clear out some of the space here, okay? So here's my 3 equations. I know I'm going fast. You have to pause the video a lot, but again, the trade-off for that is I didn't make any mistakes, or at least I did, but I found them and corrected them. So I'm going to pull my equations up here. You know what to do first. Start with your bottom equation. Negative 9z equals 36. Divide both sides by negative 9, and z equals negative 4. That's so easy. Divide both sides by negative 9, and z equals negative 4. So next, I'm going to go to this z right here, and I'm going to substitute what? Negative 4. So there it is. Here's my z right here, and I put a negative 4 right there. Okay? Now, simplify this. Negative 5, negative 4 is a positive 20. Positive 20. Then bring your positive 20 over and make it a negative 20. So you're left with negative 21. Don't forget to bring down your negative with your y. If negative y equals negative 21, then y equals 21. There we go. So I'm going to put that up here with my z. Now go to your next equation. Where the y is, you're going to put 21. Where the z is, you're going to put negative 4. So here it is. There we go. Here's the y. I put 21. Here's a z. I put a negative 4. Now let's simplify 6 times 21 and 6 times negative 4. Okay, you'll get this. 126 and negative 24. Now simplify by putting these two numbers together right there, and you'll get 102. Now bring your 102 over and make it a negative 102, and you will get a negative 99. Now divide both sides by 3, and x equals negative 33. So, there we go. There's your x, there's your y, there's your z. Guys, I'm not going to kill you with these. In your homework I'm going to give you for this lesson, you'll have 5 problems to do. Okay, I know what I'm doing. I'm reasonable. Okay, you know that by now. I'm more than fair. However, this is something you need to know how to do. And when I grade these on tests and quizzes, if you'll show all of your work and really convince me that you know what you're doing, I'll be very fair when giving you partial credit. Okay, I hope this video has been a help to you. If you have any questions, don't hesitate to call or email.